We're going to take a look at relative velocity, just the start of relative velocity. So relative velocity, there's 3 types of questions in a relative velocity question, and these are all question 2s in a paper. So the first type is 2 independent bodies, and we're going to take a look at the start of that today. There is the second type, which is body and carrier, and then there is the third type, which is the wind appears. So if we take a look at a couple of general things we need to know before we even start any of these questions, is the first thing is this is all based off the formula VAB is equal to VA minus VB. So our formula there is the velocity of A relative to B equals the velocity of A minus the velocity of B. So let's take a look at this question here for a second, and it'll make a little bit more sense. So if a car A we'll call it, is travelling at 10 meters per second, and another car B, is travelling at 7 meters per second in the same direction, what is the velocity of A relative to B? So when you're reading this, it's A relative to B. So what you're thinking of is, if it's relative to B, is think of yourself sitting in the car B, and what is car A doing in terms of what you're looking at. So if you're in the car B, you're traveling at 7 meters per second. Car A is traveling at 10 meters per second. So if you're traveling in the same direction, what it looks like to you from the car B is that car A is actually traveling 3 meters per second in the same direction as you. And the way that you get that is by using your VAB equals VA minus VB. So if we look at that question, it is just VAB equals VA minus VB. So the velocity of A relative to B is going to be the velocity of A, and the velocity of A is the 10, minus the velocity of B, and that's yourself, that's 7. So the velocity of A relative to B, relative to you sitting in that car, is going to be 3 meters per second. So that's the very, very basics of this. So what's going to happen with these questions then is they're not generally going to have them as something as basic as that. They're going to have them maybe starting off with something that looks like the second part. So if a car is traveling at a velocity of 3I plus 2j, and another car B, is traveling at a velocity of minus 2I plus 6j, find the velocity of A relative to B. So if we're looking at that question there then, so we have our velocity of A, we have our velocity of B, we're going to find A relative to B. So I'm going to use the exact same thing. So I have VAB equals VA minus VB. So my velocity of A relative to B is going to be the velocity of A, and the velocity of A was 3I plus 2j, minus the velocity of B, and the velocity of B was minus 2I plus 6j. So with these, be careful, because when you're doing this, make sure that you put them in a bracket, because the signs are going to change. So the VAB, the velocity of A relative to B, is going to be 3I plus 2j plus 2I minus 6j. So that is going to be 5i's and minus 4j. And that is a velocity. That is ms to the minus 1. Okay, so that is a velocity. Now, you'll never leave it like that, but we'll look at what you do with that now in a second. So that is our velocity of A relative to B. Okay, so the next thing we need to look at is the vector plane. Now, when we're talking about a vector plane, we're talking about, they're going to mention north, south, east, and west. So if we have a positive I, we know our vector plane looks something along the lines of just an X and a Y axis. You have your I's on this, and you have your J's on this. So it's the I is the opposite way it would be in imaginary in the complex numbers. So think of it like that. The I is on the X plane, whereas when you're talking about imaginaries, the I is on the Y plane. So when we're looking at this, we're also doing this through a north, south, east, and west kind of thing. So we have north, south, east, and west. So there is our I and J plane that we're talking about. Now what they're going to do, if I go back to this here, it says a plus I is when you're going east, or you're in an easterly direction, or it's from the west. So if they tell us that there is a car going 4 meters per second from the west, it means it's going east, so it's going to be a plus I. So if we take a look at these, the next bit then, it says the number in front tells us how fast in that direction. So for instance, if I have minus 3I, I am traveling west, so I'm going west because it's minus I, so I'm going in the negative I direction, so I'm going this way, minus I direction. unless they say anything, it's nothing to do with the j's at all. So minus 3i is going to be going 3 meters per second or kilometers per hour, depending on what the question, what everything is in terms of in the question. And you're going minus I, so you're traveling west. If I'm looking at 7j then, so pause the video for a second, think about 7j. What would happen if you were traveling 7j? So 7j, it's positive, so you're going north and you're going 7 meters per second or 7 kilometers per hour. Okay, and you can do that with loads of, with all the different ones, so minus i's and plus i's and minus j's and plus j's. Now what happens then is that we need to be able to resolve these vectors, because when we're looking at this plus I and plus j, generally what we'll have is something like we had in the previous slide, and in the previous slide we had minus 2i plus 6j or 3i plus 2j. So those questions there will bring in i's and j's, but what we're going to do is we'll look at resolving vectors, and then you'll see that being brought into it. So for resolving vectors, there will be directions given and i's and j's in them. We need to be able to use Pythagoras and sine, cos and tan to find magnitude and direction. So if we have this question here, given that the velocity of A relative to B, so we already have the velocity of A relative to B, we don't need to do the VAB equals minus, or VA minus VB, we don't need to use that at all. They've given us what A relative to B is. We want to find its magnitude and its direction. So we want to find how fast that car is going, or boat, or whatever it is, and we want to find in what direction it's going. So we have 3i and 4j. So we have VAB equals 3i plus 4j. We want to find what direction that is actually going. So I'm going to draw this in just so we have a visual of it. So if it's 3i, it's over this side 3 and up 4. So it's going to be somewhere here. Okay, and there's our VAB. So what I'm going to do is, I know that this then, if it's going over 3 and up 4, then what it's really doing is it's going straight like that. So we need to find what the speed is and what direction that's going in terms of north, south, east and west. Okay, so to do that, what we're going to do is we are going to create a right angle triangle, and we're going to use this right angle triangle then. We know for the j part, because this is j and this is I, we know that the j part is 4 and we know that the I part is 3. So there's our 4, there's our 3. And what we can do is now we can use everything we know from junior cert trigonometry to find the length of this line here, and that's going to just be using Pythagoras. So if we're using Pythagoras, we're getting the magnitude. Then magnitude is going to be the square root of 3 squared plus 4 squared. You can use Pythagoras here fully out if you want to. You'll get the root of 25, which is 5. Okay, and it's ms to the minus 1. We're going to work with meters per second here. Okay, the direction then in this case, the direction is going to be, we need to find this angle here. So to find that angle, what we can do is we can label these sides. We know this is our hypotenuse, this is going to be our opposite, this is going to be our adjacent. So when we're doing that, we can say this opposite over adjacent, so that's tan of this angle that we don't know is going to be opposite over adjacent, which is 4 over 3. Our angle is going to be the tan inverse of 4 over 3, and our angle comes out to be 53, I'm just going to round to 2 decimal places, 0.13 degrees. So when we're looking at these then, we're talking about this is going from east to north, so we're going, it's east 53.13 degrees north, or what you can say is you can say 53.1 degrees, or sorry, 0.13 degrees north of east. Either of those are perfect. So there's one answer. There is a different way of writing the same answer. Okay, they're both the same things. With these, we need to make sure that when we're resolving angles, it has to be given with respect to the x-axis. So anytime we're doing this, it's going to have to be east whatever north, or west whatever north, or west south, east south. So either of those, just make sure that it's always you're finding the angle from the x-axis. So make sure that that's what you're doing.